Right. A function of n variables or n greater than or equal to takes inputs x1 and x2 and so on till xn and returns one output value f of x1, x2 till xn. An important example is the production function of a firm QKL, which describes the amount of production the firm produces when using K units of capital and I of labors. يعني function Q هي number of amount of product. Q ده number أو amount of product. Function of K, which is capital, اللي هي money. And function of labors. Labors اللي هي workers. Function in two variables here. The function of amount of products. Okay?
Yes.
This is an example. Another important class of such functions is a class of utility functions. A utility function describes the preferences of a consumer. It enables us to compare the worth to the consumer of different competitions of two goods. The set A of elements on which F is defined is called the domain of the function. The set B in which F takes its values is called the target or target space of F. Type. Let's see what is this. Suppose the quantity Z equals f of x and y is a function of two independent variables x and y. To say that x and y are independent simply means that they don't depend on one another. Each may be chosen independently of the other to form an input x and y to the function f of x and y. Then we may think of z equals f of x and y as defining a surface in three-dimensional space. We do this by visualizing all the points x, y, and f of x, y in 3 dimensions.
But Ustaz,
Yes.
either any like obvious application you can show me to explain, because
Yes,
like,
we will come to it now. I think here. In other words, imagine that for each point x and y in the xy plane, we plot a point at a distance, z distance, f of x and y above the point. If we do this for all x, y, we obtain a surface y equals f of x. Not y. He says that we have plane, this is plane, x and y. Plane, do you know plane? Plane, like a paper sheet.
okay.
Okay. So this plane is x and y. Yeah, let's say any point 1, 2, 3, 4, 5, 6, 6, and مثلا let's say y is 8 something, 8 مثلا. So the point is going like this. The point is here. Okay?
Mhm. Yes.
And z is the third axis. This is z. So z is of function of x and y. So z, let's say z here in this at this place is here. So each x and y point, it has another value of z. So the z is like service, some sort of service. Okay.
Mhm.
The service, each point of it, it has another point of x and y. Okay.
Mm.
ماشي؟
Somehow.
طيب إن شاء الله. Like here, the following diagram shows part of the service corresponding to the function f of x and y equals to x squared plus 2y squared. The service is bowl shaped. Bowl like طبق
Yes, I
in Arabic,
understood.
with the bottom of the bowl at coordinates 0 and 0 and 0. For a fixed y equals y naught, the rate of change of z f of x, f of x and y with respect to x at x equals x node is denoted d dx d dx or df dx df dx is x node y node or f of x x node y node d d of f divided d of x. We then have a function f of x, which is a derivative of f of x and y when y is regarded as a constant. This is the partial derivative with respect to x. Sometimes the notation dz, dx, and zx are also used for this partial derivative. We said that the z is function of f and y. These are variables. This is variable, and this is variable. Variable means it is changing. It
Yes,
is not
yes.
constant number.
Mhm.
So dz, dx, it is partial derivative to x, just x, and y, he is dealing with y as a constant, as y doesn't change.
Mhm.
Note the curly d is like this.
Yes, I understood.
Rather than the normal d one encounters in the notation d of x dx for the derivative of a function f of x. يعني d of x d f divided d of x is the derivative of function f of x. So what does the partial derivative means? If we imagined yourself walking across the surface z equals f of x and y, passing through the point x node and y node, and heading in the direction parallel to the x-axis, so that your y value remain at y node. Then f of x node, y node would be an instantaneous rate at which the height of the surface increased. That is, f of x node, y node is the instantaneous rate of change of the function f when we keep y fixed at y node and change x. Thus, it is the derivative of the single variable function f of x and y node. We can define f of y equals df divided dy similarly. df divided dx and df divided dy are sometimes denoted as f1 and f2. I'm sorry, there is a lot of like
Okay, no problem.
theories, but inshallah, when we come to an example, this is important. We have
Yes,
one.
because serious doesn't make like it
Mm.
doesn't seem to be understandable.
Thus, the notation d of df divided dx or f of x and dz divided dx and z of f and f1 are all notations for the partial derivative with respect to x of z equals f of x y. Partial derivatives of important function is in economics often have special names. For instance, the QKL, Q of KL is the production function of a firm. Then DQDL is known as the marginal product of labor.
Ustaz, before we go to the example,
Yes.
can you 1 minute, please?
Yes.
I want to drink water because I feel like thirsty.
طيب.
1 minute, shukran. السلام عليكم. نعم شكرا.
Assalamu alaikum.
وعليكم السلام. Yes, I'm here.
Yes, I had a phone call.
Okay.
So this is marginal product of labor. And if you remember the marginal function, it was the derivative function. So we can have dq divided dk, and this will be marginal product of capital, right? Because k is capital, is for capital,
Yes.
and L is for labor. Right?
Yes.
So dq divided dl is for marginal product of labor, and dq dk is marginal product of capital. Example, f of xy equals 3x squared y squared plus 4xy cubed plus 7y. We compute df dx. So we need to have the derivative of this relative to x and y. We will treat y as constant. This is constant, okay?
Oh. So here, like x, it's a variable, and y, it's constant. Yes.
Yes. So the derivative of this first part will be, yani if I have f of x y equals 3x squared y squared plus 4xy cubed plus 7y. So now the derivative of x squared here is what?
It's a 2. It's a 6x.
Yes. 2 multiply 3 is 6.
6x.
Y squared. And because y squared is like number.
Yes.
Plus 4 multiply x here. The derivative of x is what?
It's 12x y.
No. Y cubed is constant.
Yes. It's just 4.
4
cubed.
Y cubed. Because y cubed is like 4. It is
Yes.
constant too. And 7y, the derivative of 7y is what?
Plus y. Just y.
No, it is 0 because y is constant too.
Okay.
So that's it. This is the derivative. That's it. Now, to compute the partial derivative with respect to y, treat x as a constant. Again, if we need to calculate df, dy, not dx. So 3x squared y squared will be?
It would be 12x. No, it would be just 6.
6
y squared.
No, derivative of y squared is 2y.
Really? Because I thought if it's a constant, it's number. We don't make.
Now y is not constant. The constant is x squared. So x squared is a constant. But y is a variable now because we are taking derivative of with respect to y.
Okay.
So the derivative of y squared is 2y. 2 multiply 3 is 6.
Yes.
And we have here y. Plus, now 4xy cubed. What is the derivative of y cubed?
3y squared.
3y squared. 3 multiply 4 is
12.
12. xy squared plus 7y. Derivative of 7y is?
Just y.
No, 7. Derivative of y is 1. 1 multiplied 7 is 7.
I just understand because if it would be x, like it would be without 7, it would be just 1.
Yes, 1 multiplied 7 is 7. We are not taking derivative relative to x. This second derivative is with respect to y, not x.
Okay.
What is this? X squared 3x cubed y. This is this is like example, like another example, right?
Yes.
Right. I write this problem here. Z equals x squared plus 3x cubed y minus y squared. And he is calculating dz dx and dz dy. Now z equals x squared plus 3x cubed y minus y squared. So he is calculating dz dx. So this is the same function. The derivative of this function with respect to x. So this is x squared. What is the derivative of x squared?
2x.
2x. And derivative of 3x cubed
Is
y.
9 squared.
9x squared y, because y is like constant now. What is the derivative of y squared with respect to x?
Just 1?
No, 0.
0. Okay.
So this is the answer. Now, what is the derivative of z with respect to y? It is the same function. Derivative of the function with respect to y. So this is what? What is the derivative of x squared with respect to y?
2x.
No, 0, because x squared is like constant now. Here we treat y as a constant.
Okay.
Here we treat x as a constant. So x squared, the derivative of constant, which is x squared, is 0. Now 3x cubed y.
It would be, so it would be just 3y or 3?
3x cubed, because y, the derivative of y is 1. Minus derivative of y squared is
2y.
with respect to y, 2y. That's it. This is the answer. Okay.
Yes.
So we may go on to define the partial derivatives with respect to x and y. So the functions f of x and f of y obtaining the second order partial derivative. Yani f of x x f of xy, f of yx, f of yy. There are also denoted by d squared f divided dx squared, d2x, d2f divided dx squared, or d2f divided dx dy, or d2f divided dy dx, or d2f divided dy squared. F of 1, 1, f of 1, 2, f of 2, 1, f of 2, 2. You will see it from examples too.
Yes,
For
because
all suitably well-behaved functions, and we shall only encounter such functions. F of xy equals f of yx. The derivatives df, dx, and df, dy are often called first-order derivatives, but we shall mainly continue simple to call them as partial derivatives. Partial derivatives. So this is another function. Z equals x squared y cubed minus 3xy squared plus y5. We will write this down. Z equals x squared y cubed minus 3x y squared plus y power 5. You will calculate dz dx and dz dy,
so it's
and
also
d2z divided dx squared. What?
I mean, like here also, like the first with respect to y, the second with respect to no.
First with respect to x, the second with respect to y. Okay. Now, the function is z equals x squared y cubed minus 3x y squared plus y power 5. Okay?
Yes.
Now, we will calculate dz dx. So this is with respect to x. So y is a constant now. Right?
Yes.
So what is the derivative of first term?
So the first is 2x y cube, yes?
Yes.
Minus 3
Mm.
y squared plus y power 5.
Sorry. Not plus, because y power 5 is constant. Right?
Yes.
So y power 5, the derivative of y power 5 is 0.
Okay.
So this is the derivative, first derivative 2x. Now we have two ways. We can calculate dz, d squared, d2z, dx squared. So we'll have the derivative with respect to x again, second time. So y is a constant again.
So we have 2y cubed minus y squared.
No, this is constant. So the derivative of constant is 0.
Okay.
So d2z dx dy is what? So now we will have derivative with respect to y. So x is constant.
Yes. And we have here 2x multiply 3 y squared, right?
No, you're right. So 3 multiplied 2 is 6.
Yes.
And this will be y squared. 6xy squared. Minus?
Minus 3, 6, 2. So it would be 6 y, just y.
Now, if we need to calculate from here, dz, dy. So it will be what? This one.
But
First
why
one.
should we calculate here? I don't understand the reason. Why should we calculate? Just second derivative, you mean?
This is the first derivative. This is first derivative. And this is second.
Okay, if it's second derivative, okay.
So now I will, but this, I will calculate now first derivative here. This is first again, first derivative. With respect to y. This was with respect to x. Here with respect to y. What?
So then,
what is the derivative of this with respect to y?
it's just 6 y squared.
Not 6. This is y cubed is 3y squared. 3. We don't have anything here. So this is 3 x squared y squared. Right?
But
we don't have number here. 3y squared will multiply by 1 x squared. It will be 3x squared y squared.
So we make the second derivative from the original.
This is not second, this is first. First derivative with respect to y.
Then I understood, okay. So then we minus.
Yes.
We write minus. We write 3x multiplied to y, or it would be 6xy.
Yes.
So it's constant number, just 1.
This is not constant with respect to y, so this is variable.
Yes, it's variable 5 y power 4.
Now we can take two ways here. We can calculate second derivative with respect to y again, or second derivative d to z with respect to with respect to x. So
first with respect to y, second derivative, it would be 3x squared multiplied to y, or it would be 6x squared y, right? Am I correct?
Yes, yes. Yes, you are correct.
And it would be just 6x, right? Just 6x. Plus second derivative, it would be 20y cubed.
Right. And here, what is the second derivative with respect to x?
X, it would be 6x y squared minus 6 y.
Yes.
Plus nothing.
0.
Yes, 0.
That's it. Okay.
Yes.
So they say here that this is like, if I write it in this color, maybe. So this is, they said that this is f of xx, this is f of xy, this is f of yy, and this is f of yx. Okay?
Yes. Okay.
d2z dx squared is 3 2y cubed minus 0. Like we did here.
Okay.
This is what he did here. And now z is function of xy, dz dx, and we have here two ways. You see here?
Here, you see.
From first derivative, this is the first derivative. And this is second derivative here. This is second derivative to z, second derivative to y, and this is first derivative to y. We have two ways here again. Second derivative of x and second derivative of y. Okay?
Yes. Okay.
So d square, this d2z divided dy squared is, you solve it like this. 6x squared y minus 6y minus 6x plus 2 20y cubed. And we did this, I think. d2z dy squared, which is here, this one. 6x squared y minus 6x plus 20y cubed. This one is this one, right?
Yes, right.
This is our solution, and this is his solution. And now, d2z dx dy, and we did it. 6xy squared minus xy. Right? Where is it? This one. 6xy squared minus xy. Right? And d squared, d2z divided dx squared. We did this. We did this for, right?
Yes, right.
Now he is saying higher order partial derivatives. Consider z equals f of x and y. Take the partial with respect to x and then with respect to x again. So this is d2z divided dz squared, which is derivative of with respect to ddx multiply dz dx. And
So,
take the, yes?
is it some kind of rule which I need to learn? Like, do I need to remake this schedule on a sheet paper to always look at it when I solve problems? Like, is it some kind of rule to which I can go when I like have problems in solving?
Yes. Yani, just you can the partial with respect to x and then with respect to y.
Okay.
So this is with respect to x. And then with respect to y, yeah, and he wrote it like this. You see?
Yes, I see.
This is with respect to x, then with respect to y, and he wrote it like this: d to z divided dz dx dy.
Mhm.
But here he is saying take the partial with respect to x and then with respect to y. I don't think so. Let's see an example. For z equals f of x and y equals x squared y cubed plus x power 4y plus x e power y. Find the four second order partial derivatives.
Mhm. Like find the 4 second order partial derivative. Why they asked 4? Like, what does 4 comes to? Like, what does it mean?
We have here four derivatives like f of x and f of xy, f of y, and f of yx. This is derivative, second derivative of z dx squared, and second derivative of z dx dy, and second derivative of z dy squared, and second derivative of z dy dz. These are four. 1, 2, 3, 4. Do you see it?
Yes, I see.
They are four. Like here, 1, 2, 3, 4.
And they all different, yes?
I see this is not different. These are not different.
I mean, but the original one, the first part, like d squared f over dx squared, like the
Let's see
derivative.
our example, what we solved here. Is this like this? Yes. 6xy squared minus 6y. Here, 6xy squared minus 6y. These are equal, but these are not different. Like dx dy and dy dx, they are the same. And here in his solution, it should be the same too. This is dx dy. They are equal. These are equal. Take the partial with respect to y and then with respect to x, partial with respect to y and then with respect to y again. So let's solve this. I write it here. Z equals f of x y equals x squared y cubed plus x power 4y plus x e power y. z equals f of x and y equals x squared y cubed plus x power 4y plus x e power y, right?
Mhm.
So dz dx, this is the first derivative,
Mhm.
is what?
It's 2x plus y
Not
cubed.
2xy cubed.
Yes, okay. Plus 4x cubed
Hmm.
y
أيوه.
plus ey.
E power y. So now we have two ways here. dz d2z dx and d2z dx squared and d2z dx dy. Hmm.
Ustaz, was the first which you wrote d squared z over dx squared, its second derivative with respect to x, right?
Yes, yes.
And what about above the second one? What does it mean?
What is above? Above where is above?
Dx squared z over dx dy.
This one?
Yes.
This is second derivative too. These are second derivative. We have 4 second derivatives. 4. This is first, second. Yes, what?
What's the difference? How they work? What's their roles? Like here
We
with
will, this one, we will take the first derivative and take the derivative with respect to x. Here we will take the derivative of the first derivative with respect to y.
That's it?
That's it.
Okay, because
So,
they look different. That's why I think they are also like plays different roles. That's why.
no. This one, the derivative, we will take another derivative, but with respect to x this time.
Okay.
So,
So here we have 6xy
no,
squared.
y 6x. We, with respect to x, 2xy cubed. With respect to x, what is the derivative of x?
With respect to x, yes. So it would be 2y cubed plus 12x squared y plus ey.
Ey is constant now. So this is 0.
Okay, understood.
The derivative of the constant is 0 because we with respect to x, no x here.
Okay. So
Now, second derivative with respect to y. Now,
yes, here we have 6xy squared. It would be 4x cubed, just 4x cubed, right?
yes.
And the ey is also constant, which means 0.
No,
Yes.
this is not constant. This is variable. We take derivative with respect to y. So ey is what is the derivative of e power x?
It's just e power x.
And this e power y is e power y.
Okay, understood.
Now, derivative, first derivative of with respect to y. This is first derivative of the original function.
Okay, so it would be x squared 3x squared y squared plus x4 plus x ey. Or we can write just ey, yes, because no, we don't. We just write like this.
And we have here number 3, and number 4. This is second derivative of z with respect to dy squared, and d to z divided dy dz. So,
Understood right now.
yeah,
Okay.
alhamdulillah. Yes.
We here say that it would be 6x squared y
Yes.
plus x4.
No, x4 is constant. We don't have any y here, so the derivative of this is 0 with respect to y, because we don't have any y.
Okay, so here we have, it would be 1.
Which one?
The last one, like x ey, or it would be x y.
X e power y, because the derivative of e power y is e power y. Multiply x, and x is constant.
Yes, okay.
Hmm.
And the next one we have here 6x y.
And we with respect to x, 6x.
Yes. So 6x y squared plus 4x cubed. Here
With
nothing.
respect to x, what is the derivative of x?
Just 1 minus 1.
1 multiply e power y. So, and you can see that this is like this. This is equal to this.
Yes.
E to z divided dy dx. I'm sorry. Equals d to z divided dx dy. They are equal.
Okay.
Right?
Yes.
So these are the 4 second derivatives.
So this is, that's it.
4 second, yes?
I mean, like that's it. Nothing else.
Nothing
Like,
else. No.
that's
Nothing else.
what we studied. Yes, it is.
Yes.
Itself. Then, Alhamdulillah, I understood.
Alhamdulillah.
It was complicated at first, but Alhamdulillah, right now it's okay. You know, Stas, I'm not a person with mathematical way of thinking. I'm opposite. I love another thing. I love psychology. I love economy. I love when it's not related to numbers. That's why it takes me time to understand.
Okay. Now, we want to check d2f dx squared is like this or not. We did it. Yes, 2y cubed plus 12, 2y cubed plus 12x squared y. And d2z dxy, dxy here, 6x y squared, 6x y squared plus 4 x cubed plus uy. So, and this is the same. And this is 6x squared xy. We did it, alhamdulillah. Okay?
Yes, okay.
Differentiate twice with respect to x, differentiate with respect to x, then with respect to y, differentiate with respect to y, and then with respect to x, differentiate twice with respect to y. So we see a comparing parts B and C of example that these are equal, although this will be true for virtually all functions that we consider in this text. It is not true for all functions. So this is not true for all functions, but in this book they will or this yani lectures they will we will study like this only. Okay.
Yes.
The chain rule. Sometimes a function of one variable is defined with reference to a function of two variables. For instance, suppose that the production level Q of a firm depends on capital and labor, like we said before, through the function Q equals K, not Q of K and L. Suppose also that both K and L change over a period of time in some known way, so that we have formulas for KT and LT, where T is a parameter measuring time. T is time, so the capital is changing with time, like each day the capital is changing, or money, and labor is changing due to time. So now Q of K of T and L of T. Can you see this, or it is not? They are now, we have Q of K of T and L of T. Not just Q of K and L. Right. For example, we might have KT equals 3 plus 2T and L of T equals 10 minus 0.2T, which means that K increases linearly while L decreases linearly as functions of time. If we know that the production function Q in terms of K and L, then we can also work out the level of production in terms of T. And so we can see how the production level will change as a result of changing time, T. For example, if Q is a function Q of K and L equals KL, just like this, KL, and K and L changes as above, we get the formula Q of
it seems to be T. Yes, QT, Q of T equal KL.
Equals this, because above he said that K equals 3 plus 2T and L equals 10 minus 0.2T. This is given before. And Q equals Q in K and L is KL. So this is like K, which is 3 plus 2T, multiply this with, which is 10 minus 0.2T. And now he will foil. He will make foil. Multiply this here, and multiply this here and here.
And get that result, yes? 30 plus 90.
Yes, 3 multiply 10 is 30. Yes. And 3 multiply negative 0.2, negative 0.6T. And 2 multiply 10 is 20T. And 2 multiply negative 0.2 is negative 0.4T. So this is 30 minus 1T plus, this is,
there's T squared to us.
I'm sorry, this is, yes. This is this is t squared. So this is 30 minus plus positive 19.4 t, right?
Yes.
Minus 0.4 t squared. This is q of k of t and L of t. For the output in terms of t, we can say it q of t direct. More generally, suppose we are given a function f of two variables x and y, both of which are themselves functions of t. We can think of this situation as defining a composite function f of t equals f of x t and y of t, like we did before. In this case, in the case of a single variable, we have a rule, the composite function rule or chain rule, which enables us to work out the derivative of a composite function. There is a similar rule here, also known as a chain rule. D of f dt equals d of f dx multiply d of x dt plus d of f dy d of x d of f dy multiply d of y dt. Sometimes in this context, we call d of f dt the total derivative of function with respect to t, to distinguish it from the partial derivatives of f with respect to x and y.
Ustaz, I have a question here.
Yes.
For what reason we use chain rule? Why is it given? Like, which function does it contain? Like, what's the function of the chain rule in this problem?
Like here, if we need to get the derivative of q, 2t, derivative dq dt. If he asks if we need to find dq dt, it will be what? It will be 19.4 t minus 0.8 t, right? Right? This with respect to t, this is 0 because no t here. T is 1, so 19.4. And this is t squared, so 2t multiply 0.4 is 0.8.
Yes,
right?
Yes.
But he is saying what? He is saying that we can find the dq dt equals to dq dk multiply dk dt plus dq dl multiply dl dt. Let's make it. dq dk is what?
dq dk, it's
from here is L. Because K is Q equals KL and dq dk from here. The derivative with respect to K, so K is the derivative of K is 1 multiply L multiply dk dt. What is dk dt? dk from here. Derivative of k with respect to t, this will be 0 and this will be 2, right?
Yeah.
Plus dq dl. What is dq dl? Is k, right?
Yes.
And dl dt. What is dl dt? From here, multiply negative 0.2, right?
Yes.
Because derivative of 10 is 0 and derivative of negative 0.2 t is negative 0.2. So
Yes.
this derivative is 2L minus 0.2K, right?
Yes.
Right, now, what is 2L? L is 10, 2 multiply 10 minus 0.2T, right?
Yes.
And minus 0.2K. What is K? K is 3 plus 2T, right?
Yes.
So this, we will multiply this here and here. And we will multiply this here and here, right?
Yes.
So I will solve it here. So 2 times 10 is 20. 2
Yes.
multiply 0.2 is minus 0.4 t minus
0.6 plus
minus
minus 0.4 t.
4. So
We have 20 minus
19.4,
minus 0.8 t squared.
and that's it. This is this.
Yes.
This is like this.
Okay.
Okay.
Yes.
This is like this. Okay.
Yes.
So this is like chain rule, just another way to solve it.
Okay.
Sometimes in this context, we call df dt the total derivative of f with respect to t to distinguish it from the partial derivative of f with respect to x and y. Example, f of x and y equals xy, and xt equals 3 plus 2xt, and y equals, it is the same example or what?
No, it's different.
Same numbers?
No. It's
3 plus 2t.
Probably yes. It's
3
yes.
plus 2t. And this is 10 minus 0.2, 10 minus 0.2t. This is the same number. And we did, you can see that the answer, the final answer is the same. Right?
Yes. We can move further.
df dt equals what we did here. What is this? df dt is
Where? Can you show me?
he didn't explain. df dt is what? We can check the result explicitly because we know from above that if t equals kaza, so df dt is this. These are the same. This and this is the same. Do you know what he did here?
It is where exactly? Can you show me? I
Here in this part. Where did he get this? We did it before. We just did it. F of xy equals xy and xt 3 plus 2t and yt equals 10 minus 0.2t. F of xy equals xy, right? And xt, x of t equals 3 plus 2t. And y of t equals 10 minus 0.2t.
Yes.
And d of f divided d of t, d of f dt is what? D of f d of x multiply d of x dt plus d of f dy multiply d of y
X.
dt. So we just solved this. D of f with respect to x is what? From here.
From here it's just y.
Y multiply d of x multiply d of t from here.
With respect to x, yes.
With respect dx dt.
Yeah, with respect to d t. Then it's 3 plus.
No. 3 will the derivative of 3 is 0.
So it would be just 2.
Yes. Plus d of f with respect to y from here.
It's y.
With respect to y.
With respect to y, just 1 x.
X.
Yes.
And dy with respect to t from here.
It says just minus 0.2.
Yes. So now we will substitute y.
It would be 2x, 2y.
Y from here.
Yes, it would be 2y, yes?
Yes, 2y. And what is 2y? 2y minus 0.2x. What is y? Y from here. Y equals to what?
Minus.
Yes.
But Usas, you say from here, from where? It's
from here.
So y it's 10 minus 0.2t.
And minus 0.2 multiply x, which is x is this.
Yes.
It is what? I write here what?
It is 3 plus 2t.
Yes. And now we will multiply this here and this here, and this here and this here. Yes.
And then we have, as we did before, it would be 20 minus 0.4t.
Yes.
Minus 0.6 plus minus 0.4t.
Yes.
And here we have 19.4 minus 0.8t. Yes, right now I understood the company.
So example number 2, f of x, y, z. We have here 3 variables. So this is x squared y root y squared plus z squared. Now df dz, we will have the derivative with respect to x, just with respect to x. So this term has x here only. So with respect to x, it will be 2x. And all this is constant, right?
Yes.
I have to erase this because this will be in the So the derivative of this is 2x
Yes.
plus 2x multiply all of this.
Yes.
So 2xy multiply root y squared plus z squared.
Yes. This
Now
part is
df dy. So this will take all of this with respect to y here and here.
yes.
Now he is going to do what?
I think he's using I forgot the name of this rule. Probably it's by how to say product rule, multiplication rule.
What is the multiplication rule?
I mean for derivatives.
Yes. Yes, it is the derivative of the first function. Like he did it like this. This is a function, multiply this function, right?
Yes.
So we can solve it here. Let's solve it here. So the derivative of f with respect to y. So the derivative of first function is what? With respect to y?
It's x squared. Squared.
Yes, x squared. Multiply the second function, which is
Y squared plus z squared
plus the
plus
derivative of this function.
yes, it's a x squared y multiply 1/2.
The derivative of this function.
So it's y multiply 1/2.
This function is y squared plus x squared power 1/2.
Yes.
So the derivative of this is what?
Here we have x squared y.
1/2. We will start with 1/2.
Okay, 1/2 x squared y.
Y squared plus x squared power. We will subtract from the power 1, so the power is negative 1/2. Then the derivative of the inside bracket.
It will be just 2y multiplied.
Multiply the first, which is multiply x squared y, right?
Yes.
So we can make it like again, this is x squared root y squared plus z squared plus 1/2 multiply 2 is we can simplify this and this, right? And we have here y multiply y is y squared and x squared, so we have x squared y squared, and this will be divided root y squared plus z squared.
Yes.
So this is a derivative
Yes.
of f with respect to y. Fine. Now, derivative of f with respect to z, last thing.
I understood. So it's the same. We write x squared y multiply 1/2 y squared plus z squared power negative 1/2 multiply 2z as we did in previous example. Instead of y, we use z.
Because this is constant. In our example, this is constant. We will not take any derivative of this. We will just derivative of this because here the z squared. We will take a derivative with respect to this. So this constant will go directly. We will not do anything in it. And the function is like this. Function of x, y, z is like this. X squared y squared plus z squared power 1/2. So we will take derivative of this part only. This part. Right?
Yes, right.
So the derivative of this part is what?
Is 1/2.
The 1/2, we will take the 1/2.
Yes, 1/2 multiplied.
And x squared y is the same. We will not do anything with it. And this bracket we will subtract 1 from this power, multiply the derivative of the inner of this bracket. So the derivative of the inner with respect to z is 2z, right?
Yes.
So we simplify 2 with this 2. So this is x squared
yz over y squared plus d squared under root.
Yes. Good. Bismillah. What is this?
I think
Subhanallah.
we didn't write.
Allah understand.
You can move further for the final answer. Also, Stas, I need to say that after 10 minutes, I have to finish because I need to go out before Maghrib to do some of my things.
Inshallah. Now, we have here 1, 2, 3, 4, 5, 6, 7, 7, another 7 slides. Implicit partial differentiation. In 10 minutes, right? What time is it now? 5:42.
Yes. I think we can complete, inshallah.
We can finish right now?
You want to finish right now?
No, if you have time, we can complete.
Like 10 minutes, inshallah, we can continue for 10 minutes.
Type. Let's see. Implicit partial differentiation. An equation g of x, y equals c can, in some cases, be solved to give y dash as a function of x dash, or y as a function of x dash. For example, if g of x, y is x squared minus y, then the equation g of x, y is 0 equal to 0 is x squared minus y equal to 0, which gives y equals x squared. Okay. Yani, if we have, he is saying that if we have g of x, y equals x squared minus y, and if we equal to this to 0, so x squared minus y equal to 0, so y equals x squared, if we take this to the other side.
Yes.
Right?
Yes.
Right. Now, in general, we say that an equation g of x, y equal to 0 defines y implicitly as a function of x if there is a function y equals yx which satisfies the equation for a range of values of x. It is often difficult or impossible to solve the equation g of x, y equal to c and find a formula for y of x. He is writing here x squared y squared plus root y x equals to, what is this? This is g of x of y. G of xy.
And G dash.
This is
No, I mean, she wrote it as two equals. The first equal G.
2 equals 2. He equals this to 0. Yes,
Yes,
is equaling this to 0.
yes, she wrote like, or it's equals G xy or 0.
Like this. I will. G of xy equals x squared y squared plus root. This is root
Yes.
yx.
Yes.
And she equals this to 0.
Or she equals is x to G xy G dash. If I understood correct.
Just like this. I don't know what is y dash is what, but from here we can write like this: x squared y squared equals root negative root y x. When we take this to the other side, if we equal this to 0, so x if we divide here by x, so we have here x equals, if we divide this by y squared and divide y squared, so we have here minus 1 over y root y. Something like this.
Okay.
But we can often still find the derivative dy dx, even if we don't have an explicit expression for y in terms of x. In fact, dy dx can be found simply in terms of the partial derivatives of g by the formula. This one. Dy dx is minus dg dx divided dg dy. Minus y minus dg dx divided dg dy. Y minus. Is your time come or what? So this is the example. You have time?
How do you think how long it would take to explain this? Like more than 10 hours, I think. Yes.
It is like 15 minutes, 20 minutes, maybe. Maybe less than this. This is just only one example.
I just afraid that the place where I would like to go will be closed. That's why I'm.
Like, خلاص, we can complete tomorrow, inshallah. You want?
Ustaz, today I know that my exam, inshallah, would be next Tuesday. It would be 23rd June. Ustaz, can we study every day until that day of exam, please? Will you have a time?
Yes, if you start morning.
Yes,
if you have time morning, I have time morning.
Yes, I also have time morning because all of my lessons already ended because we have only 2 exams, and I'm free until those exams. So I will be able in the morning